It's Mr. Sean again. Welcome back to Apologetics class. Hey, I wanted to just kind of do a little update with you before we get into the class itself. And then today, Monday, March 30th, we're going to try a Zoom meeting at 2 o'clock. And hopefully that'll go well. And it's going to be really not a teaching class like this. I'm using YouTube's because I think it gives you more flexibility to watch this whenever you want to. If your schedule's a little jumbled up right now or you have something else going on, you can watch this anytime, and you can watch it a second time if you need to, if you didn't get something the first time, like a misspelled word. Speaking of which, I had several of you get in touch with me last week to tell me that you found misspelled words. Somebody found, I think, a missing word and then a quotation problem. And each time you do that, I put one of your names, I put your name on a raffle ticket, put it in our raffle ticket bucket, and we will have some drawings. And if we don't get back to class soon enough, then I'll just do the drawings here, and I'll work out a way to mail you your gift card when you win. We'll do it maybe on a Zoom meeting or something like that. So to remind you that when you find a misspelled word, you just let me know, because I do this. Actually, I'm doing it now just kind of for fun, putting some purposely misspelled words in there. But I do misspell words from time to time, and once even had the wrong Bible verse. I think I said it was James and it should have been John. And I want to clean that up. I don't want to have those mistakes in my presentations. And so I appreciate people pointing that out. And so if you can do that for me, I will reward you with a raffle ticket, and you'll have a better chance of winning next time. Also, everybody that turns in homework, now not all of you have turned in homework, and I'll be sending out some emails hopefully this week to everybody telling you what homework I've received and what homework I have not received, so that you can make sure you get all your homework in. And when you do that, I also put a ticket in the raffle box for you then. So with your homework and misspelled words, 2 ways to earn raffle tickets and hopefully earn or win a ticket to Chick-fil-A or In-N-Out Burger. So in this lesson coming up, we're going to be talking about some fallacies, a new fallacy this time, one that we see a lot, called assumptions, and we've talked about that in class before as well. So you'll be a little bit familiar with that, I think. We have a new illusion. I don't have a magic trick for you today. Last week I had a magic trick, and I got some feedback. I showed a video of someone else doing a magic trick. It had to do with the toilet paper, and I don't know what that was. The toilet paper and throwing it over the person's head and that sort of thing. And that's it's a really cool trick. I've done it myself a lot of times, and it's almost foolproof. When we get back together, I'll show you another way to do the same trick. There's 2 ways. He was throwing it over the guy's head with his hand like that, holding him the toilet paper. There's another way to do it as well. Same effect, but just a little bit different technique. So next time we meet, I'm going to try to have something to show you in the way of a magic trick for illusions, and hopefully one that I can teach you how to do as well, so you can show it to your parents or your brothers, sisters, etc., and that sort of thing. So we're coming up on Easter week. And I remind you in the video, but I just want to remind you again, this is a great time to tell people about Jesus. I mean, what are we talking about but the resurrection of Jesus? And I think a good way to maybe start that is just to remind them that, hey, do you realize this is really real? This isn't Easter bunnies, Easter eggs, or even going to church to feel good and get together and have a big dinner. We're here today celebrating this on Easter Day because it's really true. And a good way to help people understand that, if you have someone that's really interested that says, "Wow, that I never thought of it that way. I didn't know it was true. I thought it was just kind of tradition, that sort of thing, myth, etc." Would be to give them a book. I love to give people books. I'm always giving people books. I've given you guys several books, and I was planning to give you all a copy of this book, More Than a Carpenter by Josh McDowell. He and his son Sean have updated it recently. But Josh wrote this a long time ago. Actually, he wrote it in a McDonald's restaurant in Chicago. And this is a good book that I would give to someone if they said, I'd like to know a little bit more about it. And after I've talked to them, to say, look, if you really want a deep dive, a bit of a deep dive, understand how a man who started out as an atheist and came from a pretty bad home life, actually, was an atheist, kind of a bitter guy, it seems like, how he did the research and found out it's really true. And if once you get to the point where you understand it's really true, then it's between you and God if you're going to accept Jesus or not. Some people apparently believe it's true. I believe Jesus really did live. They do believe, I guess, that there's even a God, and yet they, for whatever reason, don't want to accept him as Lord, and that's between them and God. Our job is to try to make sure they know the truth. And the truth is very important, and this is a good way to do it. There's lots of other ways too. Case for Christ is one by Lee Strobel, the gent that wrote the book that we're using for the creation, Case for a Creator. Lots of other similar books. But I really like the idea of being able to give somebody a book because it kind of gets you to, if you don't have really the the background and all the information they might want, you can't answer all their questions. If you ask them to read the book, and hopefully you've read it too, and you will read it, then you can discuss it. You can talk about it. And if there's something you guys are wondering about and you can't get the answer, there's lots of places to go look and get those answers. So I hope you have a great week. I hope you have a wonderful Easter. And remember, when you celebrate Easter, just remember and put it in perspective. We're celebrating something that happened a couple thousand years ago, but it was the most incredible thing ever to happen on earth and the most world-changing event. It was there that Jesus died for our sins, and he really did. And there's lots of evidence to back that up. So I hope you'll tell your friends and relatives that and make sure they know, at least know the truth. That's our job. Our job is pretty much done when they know the truth. And then hopefully the Holy Spirit will work in them and they'll be led to Jesus. So happy Easter. I'll be back next week and we'll meet right here and I'll see you then. Bye. All right, let's talk about the fallacy of the day. As you recall, a fallacy is a failure in reasoning which renders an argument invalid. In other words, there's something wrong with the way the person is reasoning and presenting their argument to you, and they're doing something that's going to actually render the argument invalid. It has nothing to do with the argument in favor of what they're arguing for, but it's sort of an appendage, if you will, something tacked on. So far, we've talked about the straw man, ad hominem, red herring, circular, and snob appeal last week. Snob appeal being where somebody tries to convince you if you do something, if you agree with them, then you'll be thought to be cool, or you'll be thought to be sophisticated or intelligent, something like that. That's the snob appeal thing. Today I want to talk to you about assumptions. We've talked about this before in maybe different terms, but an assumption is where, first of all, remember in Cold Case Christianity, we talked about don't be a know-it-all. Well, being a know-it-all would mean you'd bring some assumptions to the case that were not necessarily backed up by any facts, just something that you kind of assumed before you got any facts. So today we're going to talk about assumptions, and it also relates to, do we know what the other person's talking about? To be sure we know what the conversation is even about. We talked about that a Muslim might well say to you that he loves Jesus, that they revere Jesus very highly in Islam, and that's true. However, they do not believe that he is the Son of God. They do not believe he's part of the Trinity. They believe he's just a good prophet. Church of Jesus Christ of Latter-day Saints. From that, you might assume it's a church and that it has to do a lot with Jesus. And they will talk about Jesus a lot, but the Jesus they talk about, if you look at who he is, how he's described, it's not the Jesus of the Bible. It's the Jesus of Joseph Smith. And we're going to talk about that more later in the semester when we talk about other religions. So anyway, that's what we want to make sure that we know what's being said so that we're not misled. So let's do a quick little exercise here that I got from the book that we use, the Fallacy Detective. On the blackboard, you see 4 letters. They're made in quadrants. In the upper left is 1 letter. I'm not going to tell you what they are even. In the upper right is another letter. In the lower left, another letter. And in the lower right, that's not a 9, that's actually a letter. So the assumptions you might make of that is why, the question is, how are they different? How are these letters different from each other? What distinguishes them? And what are we talking about here of each of the letters that you see on the blackboard? So we would come first to A, and that's different in that it's the first letter of the alphabet. None of the others are the first letter of the alphabet. It's the only letter made with a short stem on the right. Look at the others. None of them have a short stem on the right. And it's the only vowel. So that's what makes A unique. B, this letter, that's in the upper right, this letter is different in that it's the only letter with the stem on the left of the circle. So A and B both have sort of a circle. A has a little short line coming down the right. B has a longer line going up on the left, the only one with its stem pointing upward. C is in the lower left, and this letter is different in that it's the only letter that's made of only one part. There's not like a circle and a line. It's just a continuous line drawing, and it makes a C. So it's unique in that way. The fourth one in the lower right is Q. This letter is different in that it's the only letter that doesn't follow the others in consecutive alphabetic order. In other words, we have A, B, C, and then we go to Q. We could have had A, B, C, D, but we didn't. We had A, B, C, Q. It's the only one that's made with its stem pointing downward. There's one other thing you may have missed here, though. We've talked about that, so I asked you, what makes each of these letters different that you see on the board? What's unique about each one? What about the T in the middle? Did you miss that? There's a T. The thing that I said makes the quadrant is actually the letter T. It's larger than all the others. It's at the center of the diagram. It's made with two straight lines, has no curved parts. All the others have curved parts. So the question is, did the question I asked you about looking at all the letters on the screen cause you to ignore an obvious part of the diagram, the fifth letter, the T? So again, you just want to be careful of what you assume so you don't get burned, that you're not having one conversation and the other person's having another conversation. So let's do a couple of little riddles here and see what you can come up with. I'm going to give you two of them, and then I'm going to explain to you how they work out. So at the county fair, there was a line of stalls displaying all the champion farm animals. They have, if you've ever been to a county fair, we have the Orange County Fair, all kinds of animals, anything from chickens to cows to horses, sheep, all sorts of things. So one afternoon during the fair, a man wearing a black vest walked up to the prized Jersey cow, shot her, and then ran out of the display barn. Even though there was a crowd of people around, no one tried to follow the man in the vest. Why do you think that was? So think about that. If you need to stop this video, do it. But think about it a bit, and let me give you the second riddle. Dr. Taylor lives in Chicago. He had a speaking engagement in St. Louis. He and his wife drove there in the morning. When the lecture was over that evening, they got in their car and continued to drive in the same direction they had driven earlier in the day. They didn't turn around, kept going the same way. They returned home that night about 6 hours after leaving the lecture hall. How can this be? Well, you may have made some assumptions in this. An assumption is something that's taken for granted or accepted as true without proof. You may have just written into some things or made an assumption without wondering, how can this be? There's something wrong with this story. I need to sort of take things apart again. So let me give you the answers to the two riddles. In the first one, the man who shot the Jersey cow, he shot it with his camera. He was a journalist or a photographer for the county newspaper, and he was in a hurry because he had a deadline. Did you assume about what shot meant? Did you think the man shot the cow and killed it rather than take a picture? So again, that you may have made the wrong assumption there. Second one, Dr. Taylor. He lives in Chicago, but he did not leave for the lecture from Chicago. He was staying south of St. Louis that morning, and he and his wife drove north to St. Louis to his speaking engagement. Now, afterwards, they continued driving north to Chicago. It's 6 hours north of St. Louis. So when we said that Dr. Taylor lived in Chicago, did you assume that's where he started his drive to from Chicago? So you probably assumed that and wondered, how can you keep going in the same direction without going all the way around the world and end up 6 hours later getting back home? So again, those are just assumptions. We've talked about some others, and I'll talk about more in class when we get back together, or maybe on the Zoom meeting, of times when people have completely misunderstood me or I've completely misunderstood them and really thought something really screwy is going on, only to find out there's just a misunderstanding. So kind of related to fallacies and the assumptions is the idea of illusions. Now, I was planning to try to show you a magic trick today, and I'm not going to be able to do it because I've had some problems with my video. Hopefully I'll have that resolved after Easter, and if we either get back together in person or we do this by video, I'll try to have a couple of more magic tricks to show you, and also a couple of tricks I can teach you how to do. Last week you saw the one with the toilet paper. I hope that worked. I know a couple of you tried it, and it seems like it fooled a few people, so that one was one you can do. This one is just an optical illusion. You may have seen it before, but the more you study it, the harder it is to really understand it. It's this. How many prongs are there on this thing? It kind of looks like a fork. Looks like there's 3 prongs, but then you look up at the top, and it looks like there's only two prongs coming down. And it's just the way the thing is drawn. You can look at it with your eyes, and it's really hard to sort of straighten it out. But it's there. It's just the way the lines are put together. It gives you the illusion at the bottom, because of the three circles, that there are actually three prongs coming down. When the fact is, if you look at the top, it looks like it's really just a square, not a square, but a thing made out of wood that maybe goes up, comes across, and goes down. But they've drawn that circle there in the middle, and that's what really screws up the illusion. So gives you an opportunity to look at something the first time and see something entirely different from what's really there. It's one of the more famous illusions there are. So hope you had a good time with that. And we will now turn our attention to the main lesson, Chapter 6 of Case for a Creator. Last week, we talked about in the arguments that we were giving about what evidence do we have, what points towards a creator in science. And we talked about the mousetrap. And I think some of you had a little trouble understanding what that was talking about. We're talking about in evolution as Darwin explains it. He says that the way things are put together, they're just random mutations inside the cells of humans or cells of any animal or plant. There's a mutation occurs, and if that mutation gives that animal or that species a little bit of an advantage to be able to survive a little bit more, then that animal and its children and grandchildren and great-grandchildren that will continue to have that little characteristic will continue to do much better and survive better than the ones that don't have it, because they've had some improvement, if you will. And these things happen very, very slowly, according to Darwin. They have no direction, they have no plan, they just happen. And then because of the natural selection, meaning that if you're better capable of surviving, you probably will survive better than those who aren't better capable. And it builds up over time into something maybe really good, like the ability to use your thumb or the ability to stand upright or whatever it might be, according to Darwin. He also said if it could be shown that there's anything that happens that couldn't be developed that way, say an eye, a nose, an ear, an eardrum, hearing, whatever it might be, that then his theory would fail. And the example they give, they talked about the bacterium flagellum, the little bacteria that has a propeller at the back that can move around to get to food better. And they're saying that that thing is so complex that it could not have developed piece by piece, because if you only have one piece of this propeller, the propeller doesn't work, the motor doesn't work. And the example he gives is a mousetrap. If you were saying that somehow that this was being analogous or used as a metaphor for evolution of some piece, an eye, an ear, a tongue, whatever it might be, that you would say that this mousetrap, if you tried to build it just piece at a time over a long period of time, it wouldn't give you any advantage to survive, because it's not a mousetrap until it's all there. Same way the little motor on the bacteria is not a motor and not a propeller until it's all there. So there would be no way to get there through evolution. It just doesn't work. That's a pretty good example, I think, that says there has to be something else going on. Today we're going to talk a little bit about what that might be. The chapter is the DNA and the origin of life, the evidence of biological information. This is the flagellum we were just talking about. That's what the bacteria looks like. You see the little tail on the back. Those are the things that spin around very, very fast and produce movement for the bacteria. This is what it looks like, very complicated. So the point being, of course, if you have only one of those things, if all you have is the rotor come up first and you're going to wait millions of years for the rest of it, that animal is not going to have any ability to be able to survive more than an animal that doesn't have the rotor. And around the things that we're really emphasizing is random variation and natural selection. Random means unguided, unplanned, no God, no designer, no nothing. And selection tends to imply that a mind makes this choice, not just random. So there's really very little evidence as to how. So we're not really sure how all that happens. But let's turn our attention now to the DNA, because that might give us some clue as to what's really going on here. Okay, let's get started and let Lee Strobel introduce us to Chapter 6, DNA, the origins of life, the evidence of biological information. Let's start with that, then I'm going to have another little video I'd like you to watch, kind of explaining in a little more detail exactly what DNA is, because it's very important that we know a lot about what DNA is and how it points to a creator. So let's watch Lee's video.
In 1953, Dr. Francis Crick came home and told his wife that he and a colleague had discovered the secret of life, and she didn't believe him. Years later, she said to him, "You were always coming home and saying things like that, so naturally I thought nothing of it." But this time, he wasn't exaggerating. He and Dr. James D. Watson had discovered the now famous double helix of DNA, where all of the information is stored for the proteins out of which all living things are made. But in doing so, had they inadvertently discovered evidence for a creator? Well, Dr. Stephen Meyer thinks so. He got his PhD from Cambridge University, and he believes that the information encoded in the DNA molecule is some of the strongest evidence yet for an intelligent designer. The existence of complex biological machines raises an obvious question. If natural selection wasn't the agent of their construction, then what was? The centerpiece of my investigation was an interview with philosopher of science, Dr. Stephen Meyer. Meyer, who holds a PhD from Cambridge University, brought me face to face with the most efficient information processing system in the universe. The DNA molecule and its language of life.
The discovery of the information-bearing properties of DNA and RNA is a fundamental challenge to all materialistic theories of the origin of life. Neo-Darwinism and its associated theories of chemical evolution and the like will not be able to survive the biology of the information age, the biology of the 21st century.
Meyer's conclusions are based upon his understanding of the DNA molecule and the genetic instructions that are locked within the nucleus of living cells.
In 1953, when Watson and Crick elucidated the structure of the DNA molecule, they discovered that DNA was a carrier of genetic information in the form of a 4-character digital code. That is to say that DNA functions like a software program, only more complex than anyone has ever created or devised. For a biological system to run and operate, it needs genetic information to build the proteins and protein machines that cause the cells to maintain their function.
This information is stored in a precise arrangement of 4 chemicals that scientists represent with the letters A, C, T, and G. Sequences of these chemicals provide the instructions necessary to assemble complex protein molecules that in turn help form structures as diverse as eyes, legs, wings, and hearts. This code has been called the language of life, and it is the most densely packed and elaborately detailed assembly of information in the known universe.
Geneticist Michael Denton has estimated that the amount of biological information necessary to build all of the proteins in all of the species of organisms that have ever existed on planet Earth could be held in a single teaspoon. And we'd still have room left over for all of the information contained in every book ever written. The more I learned about DNA, the more I understood the significance of what Stephen Meyer called the most fundamental question facing biology today. Where did the information in DNA come from? How did it arise in the first place?
Well, lots of people have wanted to explain the origin of information by reference to the laws of physics and chemistry or by reference to the chemical properties of the constituent parts of the DNA. But that would be like saying that you could explain the information in this morning's New York Times headline by reference to the physics and chemistry of ink bonding to paper. There is a chemical explanation as to why the ink sticks to the paper, but that does not explain the way the ink got arranged to convey a message that could be understood by speakers of the English language. Information requires a material medium, but it transcends the material medium.
An explanation for the origin of the genetic instructions needed to build the first life is the holy grail of 21st century biology. Theories proposing that this information arose through natural selection acting upon non-living molecules or the self-organizing power of chemicals in a primordial soup have repeatedly failed. Even time and blind chance, the oft-invoked saviors of implausible biological scenarios, have fallen far short as accounts for the source of the instructions in DNA. Mathematicians, for example, have calculated that a universe filled with monkeys, typing relentlessly throughout the oldest estimated age of the cosmos, would have no realistic chance of producing Shakespeare's play Hamlet, let alone a transcript of the genetic information required to build even the simplest living cell.
Based on our uniform and repeated experience, which is the basis of all scientific reasoning about the past, there is only one known cause for the origin of information, and that cause is intelligence. Whether we're looking at a hieroglyphic inscription, a section of text in a book, or a computer software, if you have information and you trace it back to its source, invariably you come to an intelligence. Therefore, when you find information inscribed along the backbone of the DNA molecule in the cell, the most rational inference, based on our repeated experience, is that an intelligence of some kind played a role in the origin of that information.
The implications of the scientific evidence, coupled with Meyer's logic, are profound. If we are finding information inside every cell and every living creature, could that not be, in a sense, the signature of a creator?
"30 centuries before science unlocked the mysteries of genetic information, or a telescope probed billions of light years into space, the Hebrew shepherd and poet David wrote eloquently of a creator who revealed his existence and power through all that he had made. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night, they proclaim knowledge. Their voice goes out into all the earth, their words to the end of the world."
God himself is invisible. He is a spirit. And yet, one of the purposes he has for us is to find him so we can know him. And he's left behind a series of clues. And sometimes we just have to kind of take our blinders off and get beyond our presuppositions and say, wait a minute, I am going to pursue the evidence of science wherever it points. And if it takes me to a very uncomfortable conclusion that there is a creator, then if the evidence points in that direction, that's the way I'm going to go.
40 years ago, a lecturer in a high school biology class convinced an inquisitive 14-year-old freshman that there was no God. Ironically, years later, it was an open-minded investigation of scientific evidence that led Lee Strobel to belief in a creator.
One of the most interesting things I've learned as I've gone on this journey of scientific discovery has been that you don't have to commit intellectual suicide to come to the conclusion that there is an intelligent designer. Because today, science is pointing more directly and more powerfully toward a creator than any other time in the history of the world. I was trained in journalism and law to respond to truth. I had to take a step of faith in the same direction that that evidence is flowing, which is logical and rational. We do that every day of our life. We make steps of faith based on the evidence that we perceive. And so it was the most logical and rational step I've ever taken to put my faith in the creator that science tells me exists. More and more people are coming to the same conclusion that I did. One of my favorite stories involves Patrick Glenn. He earned his PhD from Harvard. Like me, he became an atheist when he studied Darwinism in school. But also like me, he later reevaluated the evidence and he became convinced that there's a creator. He wrote a book called God, the Evidence. And I want to read you what he concluded. As recently as 25 years ago, a reasonable person weighing purely the scientific evidence would likely have come down on the side of skepticism. That is no longer the case. Today, the concrete data points strongly in the direction of the God hypothesis. Today, he said, there is no good reason for an intelligent person to embrace the illusion of atheism or agnosticism. What about for you? For the last 6 weeks, you've studied the current findings of science. You've offered your opinions. You've listened to the insights of other people in your group. Now, put yourself in the role of an impartial juror. What is your personal verdict in the case for a creator?
Okay, and now before we go on to the lecture, let me show you one other short video on DNA just to try to give you a little bit better idea of what it is. And don't worry, remember, I don't expect you to memorize this. This isn't a biology class or a chemistry class. I don't expect you to memorize it. What I want you to get, though, is an idea that there's a lot of information on this, and that there's a lot of evidence and very good arguments that say that the DNA that we find in our cells points very strongly to a designer, the designer that we would call the God of the Bible. So I want you just to kind of get that out of it. If you don't get the details, don't worry about it, but I do want you to just know that this exists. And down the road, maybe when you're in college someday or even beyond, or maybe when your kids are asking you, you know that you can look up this information. I'm sure it'll be updated by then and even far beyond, hopefully lots more evidence for the existence of God. But you'll know where to go to get the evidence that you need to make your arguments and not be using a lot of fallacies.
Stated Clearly presents, what is DNA and how does it work? DNA, also known as deoxyribonucleic acid, is a molecule. It's a bunch of atoms stuck together. In the case of DNA, these atoms combine to form the shape of a long, spiraling ladder, sort of like this one here. If you ever studied biology or saw the movie Jurassic Park, you probably heard that DNA acts as a blueprint or a recipe for a living thing. But how? How on earth can a mere molecule act as a blueprint for something as complex and wonderful as a tree, a dog, or a dinosaur? To help answer that question, let's first take a quick look at amino acids. Amino acids are tiny little chemicals inside our bodies that are so important, they're often referred to as the building blocks of life. There's about 20 different kinds, each with their own unique shape. The neat thing about them is they can be attached to each other kind of like Legos to produce an endless variety of larger particles known as proteins. Amino acids make up proteins. Proteins, along with other chemicals, combine to form living cells. Cells make up tissues. Tissues make up organs. And organs, when they're all put together and functioning, of course, combine to form living creatures like you and me. These proteins that make up our bodies, and keep in mind there's millions of different kinds of proteins, they each have to be formed in the perfect shape in order to function. If they're the wrong shape, they usually won't work. That's where DNA comes in. DNA does a lot of interesting things, some of which we don't fully understand, but one of its main and most well understood functions is to tell amino acids how to line up and form themselves into the perfect protein shapes. In theory, if the right proteins are built at the right time and in the right place, everything else from cells to organs to entire creatures will come out just fine. This here is a simplified model of DNA. It shows us that the steps of the ladder are made up of 4 different kinds of chemicals shown here by different colors and letters. If you look at just one half of the molecule, you can read its chemical sequence or genetic code from top to bottom, sort of like a book. A single strand of DNA is extremely long, millions of letters long. It spends most of its life coiled up like a noodle, living inside the nucleus or the centerpiece of a cell. Amino acids, however, live outside the nucleus in what's called the cytoplasm. To help DNA interact with the cytoplasm and convert those amino acids into proteins, special chemicals inside the nucleus make partial copies of the DNA code. These partial copies, called RNA, look a lot like DNA, but they're shorter, of course, and they're missing one of their sides. Their small shape and size allows them to fit through tiny pores in the nucleus, out to the cytoplasm, and into the mouth of another particle called a ribosome. Ribosomes are protein-building machines. They read the RNA code 3 letters at a time, suck amino acids out of their surroundings, and stick them together in a chain according to the RNA code. As the chain grows, it bends, it folds, and it sticks to itself to form a perfectly shaped protein. Every 3 letters of the RNA code tell the ribosome which of the 20 different kinds of amino acids should be added next. For example, CAA tells the ribosome to grab a glutamine. AGU tells it to grab a serine, and so on. Once a protein is built, it can then go on to do a number of different things, one of which could be to help form a brand new cell. So to answer the original question, what is DNA? DNA is a molecular blueprint for a living thing. How does it work? DNA creates RNA, RNA creates protein, proteins go on to form life. This entire process, as complicated, as sophisticated, as magical as it might seem, is entirely based in chemistry. It can be studied, it can be understood. I'm John Perry, and that's DNA stated clearly. Thanks for watching. If you liked what you saw, make sure to give us a thumbs up on YouTube and share it with your friends on Facebook or Twitter or wherever it is you happen to share stuff with your friends. Subscribe to us on YouTube if you want to see more videos. If you have any questions or comments, you can post those in the comment section on YouTube. We do read those, by the way. If you want to learn more about DNA and other cool stuff, check out our website at statedclearly.com. Till next time, stay curious.
Okay. Well, I hope you enjoyed the 2 videos. They might have been a little bit complicated, but in general, what the main message is, I think, this DNA is really complicated. It's really pretty spectacular, and it contains an unimaginable amount of information, real information, the same kind of information that we find in computers and in our brain. And that information always comes in our experience from someone that's intelligent, from an intelligence. Someone has to create the information and put it there. It doesn't just well up out of the muck. So as you watch the film, I wish we had time to have a little discussion, or have the ability, and maybe we can do that on our, as we switch maybe over to doing Zoom. Wondering what came to your mind as you watched the film. Did this make sense to you? Did you have any questions? Did you find anything you disagree with, or do you generally agree with it? Did it seem so complicated you just don't know? And if that's the case, that's fine. Just be knowledgeable, though, that there are a lot of people who do know, who find that evidence supports very, very strongly a creator, a designer. And what to you was confusing or didn't make sense. And at the end of this video, as I did last week, I'm going to give you my contact info. So if you have something that you think, well, this is not making sense, and I got to tell you, over the years, I've had people explain things to me and give me answers to questions I've had about the Bible or our belief in God. And sometimes those answers have been fantastic, and sometimes they've been, I kind of think, that didn't really make sense to me. That didn't really do it for me. I mean, it just didn't seem right. And then what I have to do then, what you have to do then is dig deeper, find out. Maybe there's a misunderstanding. Maybe you don't understand what's being said. Maybe you've got an assumption that's in the way. Or maybe it's not that strong an argument. And if it's not that strong an argument, fine, go find one that is a strong argument. In the course of this book, The Case for a Creator, Lee has put together quite a few arguments for in support of the existence of a creator. And I think he's done a very good job of it. And that this is kind of the pièce de résistance, the best part, I think, is the DNA. So DNA is a molecule. It has the genetic instructions that are in the nucleus of the cells. They're instructions. It's like a program. What do you do? How do you make this work? It's called the language of life. Some people have called it God's instruction book. So the question is then, where does this information in DNA come from? Where did it come from? Who put it there? Information requires a material medium, and that's like ink or this computer screen, something like that. That's where the information is being seen by you right now on a computer screen. But the information goes beyond the medium, goes beyond your computer. There's actual information being transmitted from me to you, from my thoughts to your thoughts. And there's only one reason that we know of for that, and that's intelligence. So what is DNA? What's it do? It's got this huge long name that I'm not even going to try to pronounce, known as DNA though. It's the carrier. It's the instruction manual of genetic information, tells cells how to create things inside your body to do the things that need to be done. A gene is a stretch of DNA that tells the cell how to make a specific protein. And proteins are the things that actually are building up the cells and making the body work. You have your parents' genes. Your parent, you have part of your mother, part of your father. I know in our family, some of my grandkids seem to look more like me than others. In my cousins, some of them look exactly, you would say, like their father. The resemblance is so strong that it's just, you just got to know that's Joe's kid. So you have your parents' genes, and it goes beyond just appearance of the things that they've transmitted to you. And when you get on things, you've heard of probably Ancestry.com and things like that. You can go on there and find out some idea of where you come from. Apparently there are certain characteristics of people that come from Europe, certain characteristics of people that come from Asia, South America, Africa. And you can begin to put together a picture of maybe where you came from, who your ancestors were. And each person's DNA is completely unique. I think even more unique than a fingerprint. That's why when you watch police shows, you'll find if they can find some DNA at the crime scene, and if that person's DNA is in the system, they can absolutely locate who that person was that left the DNA there. The DNA could be nothing more than a little bit of your saliva on a straw. So lots of uses for DNA, but the main use, of course, is what it's designed for, and that's to put information in our bodies to tell the cells how to form, what proteins to form, etc., to give us who we are, make us who we are. And then, of course, the issue is, what's the cause of the information? Where did it come from? The only answer we know is intelligence. They've got those 4 letters of the alphabet for our DNA, A, C, G, and T. Similar to Bill Gates hiring engineers to build computer code, DNA is very similar to computer code, and you program it different ways for different things. Bill Gates has said, and people seem to admire Bill Gates as he's the guy that built Microsoft and supposedly knows a lot about software and programming. He says that DNA is like a computer program, but far, far more advanced than any software we've ever created. It's far more sophisticated. It's astounding how sophisticated it is. So back to the question, where does it come from? Human DNA contains more organized information than the Encyclopedia Britannica. You guys may not know what the Encyclopedia Britannica is, but before smartphones and computers even, we had books. We'd have a series of books. It might take up a whole shelf of a library, maybe a couple of shelves. And it went from A to Z. And if you wanted to look up elephants, you'd go to E, and you'd look up, it's all alphabetized, you'd look up elephants. and it would have information on elephants. If you wanted to look up automobiles, if you wanted to look up Henry Ford, George Washington, it was all in the encyclopedia. So they were a big collection of books, basically. Now, if the text of this encyclopedia were to arrive in computer code on a USB drive or something from outer space, pretty much everybody would say this is proof that there's some kind of extraterrestrial intelligence. There's aliens out there, and they're smart guys. However, for some reason, when we see it in nature, it's explained as the workings of random forces, which is really odd, isn't it? That we see it coming one way, we say, wow, that's an intelligent person, an intelligent race of people writing this. When we see it in nature, we just say, just random. So there's 4 options to explain this that Strobel goes through. I'll just briefly go through them. One is random chance. Random chance means it'd be where you just try to write a book by throwing Scrabble letters on the floor. Maybe you try to design a DNA strand by just taking the 4 letters, throwing them down over and over and over and writing them down and say, I've got DNA. Or you could imagine just closing your eyes and picking Scrabble letters out of a bag and make that the first word of your book, the second word, the third word, and think you're going to write a book by that. Random chance is really, really not a very good explanation for coming up with the sophistication and all the information that's in DNA. Now, the other option is natural selection. That's Darwin's idea of how things work. You can't have natural selection before you have life. So the first life didn't have anything to do with natural selection. And Darwin never even addressed actually how life was created. He just assumed that life started, and then from there he tries to say we have natural selection as mutations occur, etc. A little bit kind of a weak starting to his book there. Natural selection has organisms reproducing into more evolved organisms, according to Darwin. But in order to have reproduction, there has to be cell divisions, and those cell divisions have to have information-rich DNA and proteins. So they don't just split up and happy things happen. There's a lot of information telling these cells what to do. One objection sometimes from people that say, no, it could have happened by natural selection is that RNA, that's the short version of DNA, was started first because it's more simple and could have been produced by natural selection. Well, the problem with that objection is RNA still needs a certain minimal amount of information to function just like DNA. It's less, but it's still a lot. So that argument doesn't work. Natural selection seems to go into the trash heap. Another one called chemical attraction. A lot of people still like this one, I think. It's not a very good argument at all, and that was that proteins and DNA could put themselves together by themselves. That's kind of like the universe creating itself by itself. And it makes sense in some areas. Salt crystals formed by sodium ions bonding with chlorine. You get NaCl, sodium chloride, that's salt. And they form highly ordered patterns with a crystal of salt. However, they're the same pattern over and over and over and over and over. There's not much information in there at all. You just get the same crystal repeating a million, bazillion, trillion times. So they do come together by chemical reaction, but there's no real intelligence going on. And what you would get, though, as it says in this last paragraph, you just get a bunch of repeating formulas. Using some of the letters of the DNA, you might get AG, 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 AG. And that would be something like opening a book and seeing nothing but the words the in the scripts. It doesn't get you anywhere. So chemical attraction doesn't work. An illustration that they used in the book was a refrigerator magnet spelling information. You could understand why the letters that spell information on your refrigerator stick to the refrigerator, but there's no interaction between them. The I is not influencing the N or the F. The M is not influencing the A. They're just stuck to the refrigerator. They're not interacting. So there's no real pattern growing there. It's just that they're going to be stuck to the refrigerator. So if I ask you, according to Strobel in his book, he says, quote, if I ask you, how did this word information get here, what would you say? That's just word information on your refrigerator. The answer comes from outside the system. You're not going to say, well, it just happened. It just kind of jumped up there. Chemistry or physics arranged the letters this way. Neither one did. It was my choice. I put those letters up there. And in DNA, neither chemistry nor physics arranged the letters into the assembly instructions for proteins. The cause comes from outside the system, unquote. That's Strobel from the book that we were reading. And today we send information everywhere, and we know it comes from intelligent agents. If you're watching this YouTube video, you know that there was some intelligence at the other end. My computer wasn't just sitting in my office and suddenly this thing appeared. It just pulled it all together somehow by magic or something. So when we see that much information, we say that it stores more information than a smaller space than the most advanced supercomputers that we have. Then we have to know that something's going on. And that gets us to the fourth option, which is an intelligent creator. An intelligent entity has quite literally spelled out evidence of his existence through the 4 chemical letters in a genetic code. It's almost as if the creator autographed every cell, Lee Strobel in the case for a creator. So I think that, to me, that does it. That really, that's the best explanation. The other explanations all fall apart. I know scientists want to try to cling to one of those to not have to have an intelligent creator in many cases, but there are many scientists who don't. They understand that there is something going on outside the system, and it's some sort of intelligent creator. They may not believe it's the God of the Bible as we do, but it's certainly pointing in that direction. Now, again, I'd love to take your questions, but I don't think we can. After this video is up, we are going to do a Zoom meeting on Monday the 29th, and hopefully we'll see if there's any questions then. But if you have any questions, I would really, really encourage you to send me an email, call me, text me, whatever you want to do, and we'll get together and try to handle those questions, because I don't want the questions to just linger there and have you think, well, I didn't understand it, so I'm not going to really use that. I don't even know how to explain it. Maybe we can work out some simple ways for you to explain it. The main thing, I think, is even if you can't explain the details, you can say to your friends, look, the DNA evidence really seems to support a creator. And if you really want to know more, I can't really reproduce it for you. I can't really explain it. But why don't I give you my copy or loan you my copy of A Case for a Creator and let you read it for yourself and then tell me what you think. That would be a great way to start a conversation, I think. One thing more before we go, I have a video that I've showed to the class from time to time. It's a little long, it's almost 20 minutes long. It's a commencement speech that was given at the University of Texas in 2014. It was given by a Navy admiral who was the head of our special forces, our SEAL teams in the Navy. And you know, I've always compared you guys, I've told you from time to time, I think of you, each one of my classes, as a SEAL team. I come from the Navy and I think in those kind of terms, so just indulge me. But the reason I do is because you guys are a very small group. You'll be even smaller as you go out to college and to high school and become adults. And you'll be out in maybe a hostile area where the SEALs often operate, in a hostile area with very small groups, sometimes even individually. And you're going to be in the same situation, except your warfare is a spiritual warfare. And so I think of my first class as SEAL Team 1, second class SEAL Team 2, and your class, the class we're in now, SEAL Team 3. And so I kind of use those analogies to sort of think of things, because you've got to be very good at thinking on your feet. You've got to be well trained, and that's what we're involved with here. Remember, we talked about training last week. Well, anyway, this admiral is a very inspirational speaker. He's been a SEAL. He is a SEAL. He's had a distinguished career, and he gives a talk on how to change the world. And that's something I think all of us would like to do, change the world for God, for Christ. And so I thought you might enjoy this. Listen to as much of it as you want. Hopefully you'll listen to all of it. And you'll be really surprised with what he says to do first. If you want to change the world, the first thing you need to do is make your bed. Your parents will probably be happy to hear that. Anyway, let's take a look.
Thank you very much. Thank you. Well, thank you, President Powers, Provost Fenves, deans, members of the faculty, family and friends, and most importantly, the class of 2014. It is indeed an honor for me to be here tonight. It's been almost 37 years to the day that I graduated from UT. I remember a lot of things about that day. I remember I had a throbbing headache from a party the night before. I remember I had a serious girlfriend, who I later married. That's important to remember, by the way. And I remember I was getting commissioned in the Navy that day. But of all the things I remember, I don't have a clue who the commencement speaker was, and I certainly don't remember anything they said. So acknowledging that fact, if I can't make this commencement speech memorable, I will at least try to make it short. So the university's slogan is, What starts here changes the world. Well, I've got to admit, I kind of like it. What starts here changes the world. Tonight, there are almost 8,000 students, or there are more than 8,000 students graduated from UT. So that great paragon of analytical rigor, Ask.com, says that the average American will meet 10,000 people in their lifetime. 10,000 people, that's a lot of folks. But if every one of you changed the lives of just 10 people, and each one of those people changed the lives of another 10 people, and another 10, then in 5 generations, 125 years, the class of 2014 will have changed the lives of 800 million people. 800 million people. Think about it. Over twice the population of the United States. Go one more generation, and you can change the entire population of the world, 8 billion people. If you think it's hard to change the lives of 10 people, change their lives forever, you're wrong. I saw it happen every day in Iraq and Afghanistan. A young Army officer makes a decision to go left instead of right down a road in Baghdad, and the 10 soldiers with him are saved from a close-in ambush. In Kandahar province, Afghanistan, a non-commissioned officer from the female engagement team senses that something isn't right and directs the infantry platoon away from a 500-pound IED, saving the lives of a dozen soldiers. But if you think about it, not only were those soldiers saved by the decisions of one person, but their children were saved, and their children's children. Generations were saved by one decision, one person. But changing the world can happen anywhere, and anyone can do it. So what starts here can indeed change the world. But the question is, what will the world look like after you change it? Well, I'm confident that it will look much, much better. But if you'll humor this old sailor for just a moment, I have a few suggestions that may help you on your way to a better world. And while these lessons were learned during my time in the military, I can assure you that it matters not whether you ever served a day in uniform. It matters not your gender, your ethnic or religious background, your orientation, or your social status. Our struggles in this world are similar, and the lessons to overcome those struggles and to move forward, changing ourselves and changing the world around us, will apply equally to all. I've been a Navy SEAL for 36 years, but it all began when I left UT for basic SEAL training in Coronado, California. Basic SEAL training is 6 months of long, torturous runs in the soft sand, midnight swims in the cold water off San Diego, obstacle courses, unending calisthenics, days without sleep, and always being cold, wet, and miserable. It is 6 months of being constantly harassed by professionally trained warriors who seek to find the weak of mind and body and eliminate them from ever becoming a Navy SEAL. But the training also seeks to find those students who can lead in an environment of constant stress, chaos, failure, and hardships. To me, basic SEAL training was a lifetime of challenges crammed into 6 months. So here are the 10 lessons I learned from basic SEAL training that hopefully will be of value to you as you move forward in life. Every morning in SEAL training, my instructors, who at the time were all Vietnam veterans, would show up in my barracks room, and the first thing they'd do was inspect my bed. If you did it right, the corners would be square, the covers would be pulled tight, the pillow centered just under the headboard, and the extra blanket folded neatly at the foot of the rack. It was a simple task, mundane at best, but every morning we were required to make our bed to perfection. It seemed a little ridiculous at the time, particularly in light of the fact that we were aspiring to be real warriors, tough, battle-hardened SEALs. But the wisdom of this simple act has been proven to me many times over. If you make your bed every morning, you will have accomplished the first task of the day. It will give you a small sense of pride, and it will encourage you to do another task, and another, and another. And by the end of the day, that one task completed will have turned into many tasks completed. Making your bed will also reinforce the fact that the little things in life matter. If you can't do the little things right, you'll never be able to do the big things right. And if by chance you have a miserable day, you will come home to a bed that is made, that you made. And a made bed gives you encouragement that tomorrow will be better. So if you want to change the world, start off by making your bed. During SEAL training, the students are all broken down into boat crews. Each crew is 7 students, 3 on each side of a small rubber boat, and 1 coxswain to help guide the dinghy. Every day, your boat crew forms up on the beach and is instructed to get through the surf zone and paddle several miles down the coast. In the winter, the surf off San Diego can get to be 8 to 10 feet high, and it is exceedingly difficult to paddle through the plunging surf unless everyone digs in. Every paddle must be synchronized to the stroke count of the coxswain. Everyone must exert equal effort, or the boat will turn against the wave and be unceremoniously dumped back on the beach. For the boat to make it to its destination, everyone must paddle. You can't change the world alone. You will need some help. And to truly get from your starting point to your destination takes friends, colleagues, the goodwill of strangers, and a strong coxswain to guide you. If you want to change the world, find someone to help you paddle. Over a few weeks of difficult training, my SEAL class, which started with 150 men, was down to just 42. There were now 6 boat crews of 7 men each. I was in the boat with the tall guys, but the best boat crew we had was made up of the little guys, the Munchkin crew, we called them. No one was over 5'5". The Munchkin boat crew had 1 American Indian, 1 African American, 1 Polish American, 1 Greek American, 1 Italian American, and 2 tough kids from the Midwest. They out-paddled, outran, and outswam all the other boat crews. The big men in the other boat crews would always make good-natured fun of the tiny little flippers the Munchkins put on their tiny little feet prior to every swim. But somehow these little guys from every corner of the nation and the world always had the last laugh, swimming faster than everyone and reaching the shore long before the rest of us. SEAL training was a great equalizer. Nothing mattered but your will to succeed, not your color, not your ethnic background, not your education, not your social status. If you want to change the world, measure a person by the size of their heart, not by the size of their flippers. Several times a week, the instructors would line up the class and do a uniform inspection. It was exceptionally thorough. Your hat had to be perfectly starched, your uniform immaculately pressed, your belt buckle shiny and void of any smudges. But it seemed that no matter how much effort you put into starching your hat or pressing your uniform or polishing your belt buckle, it just wasn't good enough. The instructors would find something wrong. For failing the uniform inspection, the student had to run, fully clothed, into the surf zone, then wet from head to toe, roll around on the beach until every part of your body was covered with sand. The effect was known as a sugar cookie. You stayed in the uniform the rest of the day, cold, wet, and sandy. There were many a student who just couldn't accept the fact that all their efforts were in vain, that no matter how hard they tried to get the uniform right, it went unappreciated. Those students didn't make it through training. Those students didn't understand the purpose of the drill. You were never going to succeed. You were never going to have a perfect uniform. The instructors weren't going to allow it. Sometimes, no matter how well you prepare or how well you perform, you still end up as a sugar cookie. It's just the way life is sometimes. If you want to change the world, get over being a sugar cookie and keep moving forward. Every day during training, you were challenged with multiple physical events, long runs, long swims, obstacle courses, hours of calisthenics, something designed to test your mettle. Every event had standards, times you had to meet. If you failed to meet those times, those standards, your name was posted on a list, and at the end of the day, those on the list were invited to a circus. A circus was 2 hours of additional calisthenics, designed to wear you down, to break your spirit, to force you to quit. No one wanted a circus. A circus meant that for that day, you didn't measure up. A circus meant more fatigue, and more fatigue meant that the following day would be more difficult, and more circuses were likely. But at some time during SEAL training, everyone made the circus list. But an interesting thing happened to those who were constantly on the list. Over time, those students who did 2 hours of extra calisthenics got stronger and stronger. The pain of the circuses built inner strength and physical resiliency. Life is filled with circuses. You will fail. You will likely fail often. It will be painful. It will be discouraging. At times, it will test you to your very core. But if you want to change the world, don't be afraid of the circuses. At least twice a week, the trainees were required to run the obstacle course. The obstacle course contained 25 obstacles, including a 10-foot wall, a 30-foot cargo net, a barbed wire crawl, to name a few. But the most challenging obstacle was the slide for life. It had a 3-level, 30-foot tower at one end and a 1-level tower at the other. In between was a 200-foot-long rope. You had to climb the 3-tiered tower, and once at the top, you grabbed the rope, swung underneath the rope, and pulled yourself hand over hand until you got to the other end. The record for the obstacle course had stood for years when my class began in 1977. The record seemed unbeatable until one day a student decided to go down the slide for life head first. Instead of swinging his body underneath the rope and inching his way down, he bravely mounted the top of the rope and thrust himself forward. It was a dangerous move, seemingly foolish and fraught with risk. Failure could mean injury and being dropped from the course. Without hesitation, the student slid down the rope perilously fast. Instead of several minutes, it only took him half that time. And by the end of the course, he had broken the record. If you want to change the world, sometimes you have to slide down the obstacles head first. During the land warfare phase of training, the students are flown out to San Clemente Island, which lies off the coast of San Diego. The waters off San Clemente are a breeding ground for the great white sharks. To pass SEAL training, there are a series of long swims that must be completed. One is the night swim. Before the swim, the instructors joyfully brief the students on all the species of sharks that inhabit the waters off San Clemente. They assure you, however, that no student has ever been eaten by a shark, at least not that they can remember. But you are also taught that if a shark begins to circle your position, stand your ground. Do not swim away. Do not act afraid. And if the shark, hungry for a midnight snack, darts towards you, then summons up all your strength and punch him in the snout, and he will turn and swim away. There are a lot of sharks in the world. If you hope to complete the swim, you will have to deal with them. So if you want to change the world, don't back down from the sharks. As Navy SEALs, one of our jobs is to conduct underwater attacks against enemy shipping. We practice this technique extensively during training. The ship attack mission is where a pair of SEAL divers is dropped off outside an enemy harbor and then swims well over 2 miles underwater, using nothing but a depth gauge and a compass to get to the target. During the entire swim, even well below the surface, there is some light that comes through. It is comforting to know that there is open water above you. But as you approach the ship, which is tied to a pier, the light begins to fade. The steel structure of the ship blocks the moonlight. It blocks the surrounding street lamps. It blocks all ambient light. To be successful in your mission, you have to swim under the ship and find the keel, the center line, and the deepest part of the ship. This is your objective. But the keel is also the darkest part of the ship, where you cannot see your hand in front of your face, where the noise from the ship's machinery is deafening, and where it gets to be easily disoriented, and you can fail. Every SEAL knows that under the keel, at that darkest moment of the mission, is a time when you need to be calm, when you must be calm, when you must be composed, when all your tactical skills, your physical power, and your inner strength must be brought to bear. If you want to change the world, you must be your very best in the darkest moments. The 9th week of training is referred to as Hell Week. It is 6 days of no sleep, constant physical and mental harassment, and one special day at the Mud Flats. The Mud Flats are an area between San Diego and Tijuana where the water runs off and creates the Tijuana Sloughs, a swampy patch of terrain where the mud will engulf you. It is on Wednesday of Hell Week that you paddle down to the Mud Flats and spend the next 15 hours trying to survive this freezing cold the howling wind, and the incessant pressure to quit from the instructors. As the sun began to set that Wednesday evening, my training class, having committed some egregious infraction of the rules, was ordered into the mud. The mud consumed each man till there was nothing visible but our heads. The instructors told us we could leave the mud if only 5 men would quit. Only 5 men, just 5 men, and we could get out of the oppressive cold. Looking around the mud flat, it was apparent that some students were about to give up. It was still over 8 hours till the sun came up. 8 more hours of bone-chilling cold. The chattering teeth and the shivering moans of the trainees were so loud, it was hard to hear anything. And then one voice began to echo through the night. One voice raised in song. The song was terribly out of tune, but sung with great enthusiasm. One voice became 2, and 2 became 3, and before long, everyone in the class was singing. The instructors threatened us with more time in the mud if we kept up the singing, but the singing persisted. And somehow the mud seemed a little warmer, and the wind a little tamer, and the dawn not so far away. If I have learned anything in my time traveling the world, it is the power of hope. The power of one person, a Washington, a Lincoln, King, Mandela, and even a young girl from Pakistan, Malala. One person can change the world by giving people hope. So if you want to change the world, start singing when you're up to your neck in mud. Finally, in SEAL training, there's a bell. A brass bell that hangs in the center of the compound for all the students to see. All you have to do to quit is ring the bell. Ring the bell, and you no longer have to wake up at 5 o'clock. Ring the bell, and you no longer have to be in the freezing cold swims. Ring the bell, and you no longer have to do the runs, the obstacle course, the PT, and you no longer have to endure the hardships of training. All you have to do is ring the bell to get out. If you want to change the world, don't ever, ever ring the bell. To the class of 2014, you are moments away from graduating, moments away from beginning your journey through life, moments away from starting to change the world for the better. It will not be easy, but you are the class of 2014, the class that can affect the lives of 800 million people in the next century. Start each day with a task completed. Find someone to help you through life. Respect everyone. Know that life is not fair and that you will fail often. But if you take some risks, step up when the times are the toughest, face down the bullies, lift up the downtrodden, and never, ever give up. If you do these things, the next generation and the generations that follow will live in a world far better than the one we have today. And what started here will indeed have changed the world for the better. Thank you very much. Hook 'em horns.